So good afternoon. Let's start the day 3 second session. So today we have the resource person Dr. Sri Mageshwari from Kongu Engineering College. So she is going to talk about the Iot architecture and the smart PLCs. So let me invite Basil Baby for introducing the speaker.
Today, the speaker of the session is Dr. C. Maheshwari. She's an associate professor, Department of Mechatronics Engineering, Kongu Engineering College. And to her credits, she has 25 reputed journals, 28 international national conference, and 5 funded research projects. She has also 4 consulting projects, and she has organized 4 funded programs. And under her guidance, 3 ongoing research scholars. And her research areas are IoT, remote monitoring and control, data analysis, servo control, mobile robotics, and machine learning. So I invite Dr. C. Maheshwari Madam for this session.
Yeah, thank you for the introduction, sir. And it gives me an immense pleasure in joining with you in ACT sponsored 1-week online Sttp program on IoT-based manufacturing and design. And I would like to hand over this session. I think this session will be a useful one for you. So let me share the screen, my PPT. I think, sir, can you stop sharing your PPT so that it will be enabled for me?
Now you can now share your PPT.
Yeah, 1 second. I think it is visible to everyone, right? Yes,
Yes,
sir?
yes,
Yes, we shall start. Now today's topic of discussion is smart and integrated PLC, IoT architecture for plant monitoring and control. So today what I'm going to explain to you is in a manufacturing sector, what is the importance of PLC, how the hardware can be interfaced with the PLC, and what is the basic architecture of IoT. And with a simple case study, I have 3 different case studies. And what we have done is a research as my students, as well as my PG scholars and all, and how we have implemented this IoT architecture for our plant monitoring and control functions. And I would like to touch upon what is nothing but the machine learning algorithm, which what we have used in our project and all. Okay, so it will not be a general one. Like my agenda will be like what is a PLC and what is simply nothing but SCADA. First of all, PLC is nothing but programmable logical controllers, and SCADA is nothing but supervisory control and data acquisition system. And this IIoT is nothing but industrial Internet of Things. And I'm going to explain you some basic, some case studies. With the help of that, I can explain you how we have implemented or how we have used the IoT architecture for plant monitoring and control functions. So this is what the agenda. And simply what is called as an industrial automation. So in order to perform automation function, we are going with this IoT kind of architectures and machine learning algorithms in industries. And basically I belongs to a mechatronics engineering, but we are the integrated branches where how the electronic and control functions can be implemented towards mechanical systems. That is, we have the subjects related to this control engineering, basic electronics, and PLCs and automations, robotics and all, and how it can be implemented to our mechanical systems. Like students will be studying strength of materials, dynamics, kinematics, and all those things. And but sorry, I'm a automation engineer where I belongs to basically EEE, electrical and electronics. My PG is mechatronics, and I have completed the PhD in industrial automation. And my scholars, we have undergone with some mechanical systems. We took some mechanical systems, and on that we have implemented some IoT based algorithms. Since in this scenario, We cannot claim that I'm the mechanical engineer. I cannot able to perform some plant monitoring and control function. I don't know what is IoT and all. But we cannot tell like that. But we supposed to know what is IoT is. But simply what you can do is you have to know the basics of how it can be implemented, and we suppose have to get help from the computer science and IT people. That is what we done for our project, and that is simply like Java coding and Python coding. We are not familiar with, but however we can integrate with them, and we will ask them to collaborate with us to develop these industrial automation functions. Like it's simply the industrial automation basically is nothing but for remote monitoring and control of a particular system by acquiring data from that particular industrial functions. So it facilitates to increase the quality and all. I don't want to tell you the basics and directly go away with the basics of. First I'm going to explain you the concept of PLC. Why I'm right away going to this PLC is nothing but it's the programmable logical controllers in whatever the industries. If you want to acquiring a data, basically you're supposed to have a microcontroller based system or a PC based control system, or you're supposed to have a PLC. So PLC can be used in industry for rugged environments where, for example, your manufacturing industry, you're supposed to manufacture, you're going to run a CNC machine that should be run it for X and Y axis with the help of servo motors. Those can be controlled with the help of PLCs. So, but for applications, if you want to develop an application of your own, and how can I can use this PLC? So, one example I can tell you, one agri scientist who asked us to help us to integrate their sensors. Like, for example, they're monitoring the crop diseases which have been occurred in the farm field, and they asked us to how to interface those sensors with the PLC. Like if you're a mechanical engineer or an electrical engineer or a computer science engineer or whatever it may be, if you want to get data from the field, you're supposed to acquire some controller. And for in industries, all the industries, you might have seen some of the industries, they will be using a PLC. So this PLC is nothing but simply a microcontroller. So this microcontroller, I don't want to have the basics of what is microcontroller and how it is working. I don't want that. But a mechanical engineer can simply able to interface the IOs with the PLC. So some of our mechanical students and are doing laboratory with our PLC based working softwares under industrial automation. So here I can show you. So this is nothing but a modular PLC where so this is simply nothing but these wires through which you can connect input and output devices. So while you consider input and output, it means, for example, if you interface a switch, that is, for example, a simple switch that is called as a discrete input device. And for example, if you want to interface a sensor, for example, if you want to measure the temperature in your room, that is a parameter that is varying with respect to time. So that is nothing but an analog parameter that can be interfaced, that cannot be directly interfaced with this base PLC. So we have the different slots which are available with the PLC. What are the slots? First one is the control part, second one is the communication part, third one is the digital input, and fourth one is the digital output, analog input and analog output. So many slots which are being available. This is called as the racked PLC, where you can interface discrete as well as analog devices with this. Okay, so what is discrete and analog? If the parameter, for example, in manufacturing plant, if you want to measure the speed of the motor which is being run, that is connected with the shaft of your CNC machine, the speed need to be monitored. The speed parameter, how it can be monitored, then you have to connect a tachogenerator or sensor that need to be interfaced control module. So this control module, if it is analog type, so analog type of sensor inputs can be interfaced through this analog modules. So this is two types of PLC which are being available in market. If you take this compact PLCs, here you can connect one or two analog input devices, but cost wise it's starting from 5,000 to 10,000. But once you consider if it is for plant monitoring and control, this is racked PLCs, this will be more costlier. So once you consider the manufacturers of PLC, so this diagram which I've shown you is a manufacturer of Allen Bradley. So this is also Micrologics manufactured by Allen Bradley. So we have the famous manufacturers of PLCs. the topmost manufacturers are Siemens PLCs, and second topmost will be your Allen Bradley, and third topmost will be Mitsubishi PLCs. So the manufacturers who are from US, German, as well as from Japan, and based on the company which are situated in our country, they are going to use the PLC. Like for example, Allen Bradley is manufactured from US based companies which are being available in India, they will be using AB PLCs. Like Siemens is from German. If German based companies or German based marketing companies, they will be using Siemens. And third one is if Japanese based companies, they will be using Mitsubishi. The same common used PLCs and manufacturers. So histories, it starts with 1970s, and it is for the purpose of automation manufacturing industries. It performs relay equivalent functions, and also it performs on and off as well as analog performance also. So there are some programming environments which are available with the PLC, and I know the mechanical engineer cannot able to perform a programming on a PLC. But however, once you learn how to develop a ladder logic diagram, it is very simple for a simple automator, a diploma level operator can able to develop the programming, as well as he can able to dump the programming, he can able to perform a monitoring and control function. That this is what the simple facility, simple and easy programming language, which is being present for PLC. So which is the most advantage, so that this can be used mostly in industrial environments. And this is used for industrial environment. It is used for ease of use and maintenance. Okay. So what are the functions that it can able to perform, like arithmetic, data manipulation, master control relay functions, and sequencing and all. So don't worry, I'm not going to explain you about this PLCs and all. And this is simply, you can connect your inputs. Here you have your controller, here you have your outputs. So simply I can able to tell you what kind of inputs that I can able to give you. Like for example, in your plant, if you want to connect a 24-volt DC input, like for example, you're having your cabin. So in your cabin, if you want to enter inside your cabin, or if you want to count how many students or how many persons who are entering into your cabin, what you will do is you will simply going to fix a sensor called as a proximity sensor. That proximity sensor is the non-contact type sensor, can able to sense how many that is how many objects which are being crossed. It may be a metallic or it may be a non-metallic. Or for example, if you assume that in a manufacturing industry, you're going to connect this sensor on a conveyor where the metal objects are being traveled in that conveyor. So this particular sensor is used to sense how many parts which are being moved on the conveyor. Okay, how it can be done, it should be interfaced with the PLC. So here it should be interfaced at the input module of the PLC. So these are all some of the symbols. Like this is the common symbol for a proximity sensor. Here, for example, at different voltages. So why I am choosing PLC than your Arduino or embedded or simple data acquisition cards? Here it is because this input can be interfaced with any kind of supply voltage, like the input device can be operated with 12 volt DC or 24 volt DC or 230 volt AC or 110 volt AC. That can be interfaced with this PLC directly. That can be possible. But as a mechanical engineer, I don't know what is how it functions and how can I develop a programming. Simply in your programmable controller, you can develop a ladder logic based circuits. And based on the inputs, based on the logic sequence you are writing, what logic sequence you will be writing, you have to think over it. Like for example, what you will do, you will be finally performing in all controller functions, you will be performing only arithmetic and logical functions. Like for example, you are going to measure two sensor inputs, temperature 1 and temperature 2. You have to find out the temperature difference and which one is the greater. On based on that, you have to turn on some output. So this is what you can do. Here, what you are going to do, in order to compare this, you have to perform a compare function, or you have to perform a separate function. Or else, if the temperature in the room will be greater than 50 degrees centigrade, I need to turn on the cooler. If the temperature is less than, greater than 70 degrees centigrade, so I need to turn on some other indicator output devices. So in this case, you have to perform a compare function. So in all the control functions, you have to perform only arithmetic and logical functions. That way in a controller, it is not simply for a PLC, since the PLC consists of a microcontroller. So this microcontroller is the basic hardware which is available in your personal computer. It is available in most of all control hardwares which are available in the market, wherein we are going to see about the IoT. That IoT is also consists of a microcontroller. So the importance of, you don't want to know the basic structure and working of this controller, but you're supposed to know the how the working of the microcontroller takes place in all these devices in a different way. Like for example, in PLC it works in a different way. In basic microcontroller it works in a different way. In IoT it works in a different way. So that is what we. So this is the common functions. This can be done by all the microcontrollers. Okay. The box size and the box structure only will be the difference, but internal working are same. So like inside PLC, it has input and it has processor, memory, and it has outputs. Like you have to develop your programming. That programming will be stored in memory, and based on the input conditions, you are going to write a sequence. Like if input 1 and input 2 are same, I need to turn on this indicator light. That is what the sequence that you are going to write with the help of ladder logic. That will be dumped into your memory. That will be communicating to your processor. This processor sends the input and it turns on the output accordingly. So this is what the simple PLC based architecture. It is not tough one, and I don't want to have how the processor was working, how the coding is to be done, everything. I don't want to work it out. Okay, so this is what where to use your conveyor control, predict the circuit boards, SCADAs, machinery trust, fertilizer industries, so many applications you can use your PLC. So like for example, input devices, what all the is very important in all the control devices. It is for example for an IoT or whatever it may be, all the control devices, you must understand what is called as your input, and that you are getting from the field is called as your input. The device that you want to control is called as your output. Like for example, push buttons and photoelectric proximity, motor starter contactors, and relay and thumb wheel switches, all are called as your input devices, and which can be operated with the voltage of 120 or 24 volt DC, and which can be operated with two different concepts like called as sourcing as well as called as syncing. This deals with how can you interface these devices with your hardware. So similarly, kind of output devices, these are the actuators that is called as the device that you want to control. Like for example, I want to control a valve to be opened or closed, solenoid to be on and off, and relays to be on and off, alarms to be indicate, and lights to be on and off, fans to be on and off. So these are all some of simple output devices. How these can be controlled? What it's a triad or transistor. I don't want to because these are all coming under power electronic basics, and these relays basically operate with relays. So if you're in this group, if you are really interested in doing a plant monitoring and control function, first you have to go and search it on what is called as relay and what is called as relay logic based control functions. It's very simply simple hardware based controls, and once you learn, then you can able to really understand what is called as your PLC. So simply, and how can be a devices connected? Sourcing is nothing but a positive side of the output. Positive side of your power supply is being connected with the load, and then negative side is connected like this. This is called as, for example, here. This is your input device. This is a switch. This switch is connected at the positive side of your power supply. Normally, in control panel wiring, if you look into it, so this positive side of your whatever may be your input, a sensor or whatever it may be, the plant monitoring functions, all these devices, if it is connected through the positive side, that is called as your sourcing, and if it is connected to the negative side, that is called as the syncing. So most commonly used type will be the sourcing. If you look into a control panel which is being available, all negatives will be common together and it will be connected to the negative side. All the input will be connected through the positive. Why it is required? Because if you know this, only you can connect your input device with your PLC. Like in terms of your input, this is your sourcing, and in terms of outputs, so field device will be connected. So a separate DC power supply is required. So this output module, for example, you are going to connect a lamp, that is your field device that will be getting output from the PLC, and this VDDC is given. So negative power supply is given through the power supply, and it should be given to the PLC also. So output positive is given to the field device, that is called as your sourcing, and opposite will be your syncing. So field output device will be connected through the negative, because your DC power supply, DC common negative will be looped through the PLC output device. So this once you wired your IO device with your PLC, you can able to understand what is called as your sourcing and syncing. So in industry, through the way it is being working, a simple PLC application. So here, whatever may be the plant monitoring and control function, this is a simple mixing tank. This mixing tank is being connected with the motor. This is called as a stirrer motor. First one, you have ingredient A, which is coming to this particular tank, which is being controlled by a solenoid. And then the level of the liquid which is being filled on the tank, which is being measured by sensor 2 as well as sensor 1. So sensor 2 at the lower level, sensor 1 is at the higher level. And then ingredient B is coming, that is being controlled with the solenoid 2. So now the problem statement here is, when a start button is pressed, this is your input device to the PLC. Ingredient A should be coming to the tank. So it should be coming, it should fill up the tank until the sensor 2 is senses. So this is a feedback to your PLC. It is an input device to the PLC. Until that, the solenoid 1 should turn on. So now you have to check the logical status. Start should is equal to 1, sensor 2 is equal to 0, so that the solenoid 1 is in on condition. When sensor 2 is equal to 1, that is it is sensed and output indicates that there is a liquid that reaches at this level. When it is equal to 1, the solenoid is getting turned off. Then after that, the ingredient B need to be turned on. Up to what? Up to the tank which is filled up to sensor 1 which is being sensed. So after sensor 1 senses to 1, the ingredient B should turned off with the help of this solenoid 2. After solenoid 2 is getting turned off, this motor should run for 30 seconds. And then after 30 seconds, the byproduct should be turned out from this particular tank. This is a simple chemical mixing process, or whatever it may be, some mechanical process. You are going to mix some chemicals that can be given as the, for example, lubricant, which may be given to the CNC machine or whatever it may be. When two liquid is being appropriately mixed, that liquid may be given as the output. So this is also can be done as a this function. So like here, how can we operate with solenoid 1, 2 motor and solenoid 3? You have to work it out. Accordingly, you have to develop a programming. So I'm not going to explain you in depth about this. And how can I develop a programming next? So this is a problem which is given to me. Like this is a problem, you have to perform it. So I have to check it out, what are the input and output. These four are the outputs, and what are the input, start and stop, sensor 1 and sensor 2. Based on the feedback, I need to develop a programming. So now, how can I develop a programming in a PLC? So I have to use a ladder logic programming, function blocks and structure text. So next slide will be explaining. So this is the ladder logic. All the input will be given as the corresponding equivalent addresses, and then I have to develop. So if input 1 is on, you have some arithmetic and logical function. Based on that, you can generate a coding. Like it's a so you don't want to. So the very important thing why we are going for this PLC is very simple coding, where even a mechanical engineer or whatever chemical engineer can able to understand, and he can able to develop the sequence of functions. So that's why it is very famous, the ladder logic programming using a PLC. So here what you have to do is you need to use a PC. You have to develop your ladder logic programming. You have to dump that programming into this hardware. So that's what you have to do. And what are the different operations that you need to perform, that you have to what are the factors that you need to consider it for it. For example, all part okay, so a very big problem need to be divided into small different problems. You have to select appropriate languages. So these are all general remarks, I don't want to go in depth. Like here I need to explain you what are all the programming languages which are being available. Okay, so for continuous operation for Boolean variables, mostly ladder logic diagram is used. If the process analog and as well as the process continuously takes place, then function block is used. Sequential function start is also used. But it is not like you should not use the analog programming. You can use it the ladder logic for all the programming functions also. So these are all the three programming languages which are being used. Structured text is the programming language which is equal to a Python or C programming language. But if you're very good enough in programming, like your software programming, then only you can choose your structured text. Otherwise, we have to go with the ladder logic. So next, first I have introduced what is simply called as a PLC, and second one is what is called as a SCADA. Now what you have to do is you have to develop a programming using a PLC. All the input and output devices like your sensors and your solenoid and your motor need to be connected with the PLC. That field devices are connected with the plant. Okay, now what is called as a SCADA. So this is very much important in all the power plants or whatever it may be in manufacturing industries. You might have seen all these control panels. So this is nothing but a SCADA control panel, where these control panels are used to display the plant plant activities, like what is going on in the plant. For example, what is the temperature with respect to time in the boiler one, what is the pressure, maximum pressure need to be built inside the boiler, and what is the pressure as of now. All those data can be monitored as well as visualized with the help of this SCADA screen, and also this can able to control. So this is called as supervisory control and data acquisition systems. So supervisory control in the sense, we have like 100 number of PLCs in your plant, total manufacturing plant. For individual CNC machine, let us assume individual CNC machine will be operated with a PLC. All these PLCs must be integrated together with the help of wide area networks. All these communication signals need to be given into a common station called as a SCADA. So where the SCADA need to be used for perform monitoring as well as control functions. So let me look into this is a gathers information such as where a leak in an oil pipeline. Actually, this is a statement which is given in the book, but however, it simply suits with my application. What I'm going to explain you as a oil pipeline station, how the parameter can be monitored, how the IoT can be interfaced, and how the data analysis algorithm can be used. That is what my case study will be. And here the definition which is given for you is SCADA system which gathers information. Like for example, where a leak on a pipeline has occurred and it transfers the information back to the central sites, then alerts the home station that the leak has occurred and carrying out the necessary analysis and control, such as determining if the leak is critical and displaying the information in a logical and organized fashion. This is what the definition which is given. So you might be understand this. There is a central monitoring, a very big PC is available. That personal computer is going to gather all the informations and it is going to display whatever may be the normal abnormal functions which is being occurred in the plant. So this SCADA in a higher end, now it is called as the IoT front end. So this SCADA, using a simple server, local servers, we are going to integrate or we are going to acquire the information. Whereas if it is in using internet, if you are acquiring a data, that is nothing but your IoT front end. That is what the difference between basic SCADA and your IoT. So now what is the traditional control, which is being individual servers are being connected with this computers, which is being monitored. So our next one is nothing but a SCADA, which is being communicated through a distributed database, and then the data acquisition is being takes place. Different PLCs and different SATA servers will be communicated through a common communication bus, and the common platform called as the central host computers, which are being used for data logging, archiving, access control, and alarms. And it is for graphics and batch processing. It means what? To indicate the operator that the plant has going in an abnormal condition or whatever it may be. How it is being done? It is being done with the help of simply your PLC. So one in previous slide, I have explained you the basics of what is called as a PLC programming. Once you can able to develop a PLC programming, all those tag address. What is tag address? Like for example, your start switch or your sensor, as called as that sensor is connected to the PLC. That how can I read that input with the help of its address? Some address may be given for that input. That is called as the tag address. So once you acquire the tag address in the software, there are many softwares like I have told you. The manufacturers of PLCs like Siemens, Allen Bradley, and Mitsubishi, and so many other manufacturers are being commonly available in the market. All those manufacturers are simply having the hardware called as HMI, called as Human Machine Interface. It is otherwise called as a SCADA system. Okay, so that system, it's like a PC, where not like a PC, your touch mobile phone. It's simply like a touch mobile phone, and you can design the screen of the touch mobile phone. You're having your touch mobile phone, you can design the screen. How you can design the screen? You can draw like a symbol, like computer symbol or whatever it may be, the symbol which you require. So let me, yes, this one is nothing but how can you configure, like a PLC can be communicated through a SCADA. All the IOs is being communicated directly through this field bus. There is a server called as open access server called as OPC data server, through which data can be communicated. So there is a separate software used for this programming. There is, for example, if you take your PLC, Allen Bradley and Rockwell Automations, they are giving RS Logics or Studio 5000 based programming softwares. Whereas if you are taking your Siemens, they are giving a TIA portal, that is called as totally integrated software portal they are using. So for example, Mitsubishi, if you're choosing a Mitsubishi PLC, they're having a separate software, but I don't much aware about that. And now those are all being communicated with the common OPC server through this SCADA software. Like Siemens is also having a separate Step 7 PLC, SCADA software. And Rockwell, Allen Bradley PLC, they're having a separate software. Whatever it may be, the PLC or HMI SCADA system that you're taking, there is a common communication medium is used to transmit the data. So like this HMI screen, what it is for used, it is for performing all those functions. So let me tell me how an operator interface will be look like. So here the operator interface, the total entire plant, so whatever may be the realistic diagram that I required, I can able to pick and place. You can right click on it, you can map the tag of your PLC programming, so that for example, here you are going to connect a so here is, for example, assume that it is a stirrer motor. In a previous example, if stirrer motor is on, like corresponding tag address, if it is getting turned on, then it indicates, or if you have an animated display, then it shows you it shows you like it is rotating, or otherwise it will shows you color changes will be occurring in the SCADA screen. Just you have to perform a tag mapping. Okay, so this is what a typical screen. So here it shows the trend, that is what is the data that is changes with respect to time. So this is the very basic in your big data analytics and data analytics of your IoT, where how the data is being transferred. Like in your PLC in local server, you can able to store a data. That data can be transmitted, those sensor data can be transmitted to your cloud, and those data can be saved with respect to time. But here in offline, what I have to do, I have to download it and I have to save it in an Excel file so that it will be maintained for a longer time period. Whereas if you access all these data in your cloud, then automatically the data, historical data will be saved. So this is what the difference. So here, like what are the tags that can be to be connected with this field can be indicated here. So this is simply like a HMI. It is in a general way, in PLC it is called as a HMI. In general way, it is called as a SCADA. So next one we start with. So I have explained you the basics of PLC and what is called as a SCADA, basics of SCADA. And next one, the basics of what is called as an IoT. So I'm not going to much discuss about IoT because so many there's so many lectures that you have attended. They might have explained you what is called as an IoT. But in my perspective, I've gone through a video, so they have given some insights of what is called as an IoT. That's why I've taken. So here you are going to take an internet, like you don't require a PLC first to interface your IoT, right? So it is a hardware where the direct sensor information can be interfaced into your common center IoT cloud. So using your mobile phone, you can turn on your off your bulb, your light and fan and AC on your room. It is called as your smart home automations. Now Schneider Electric is the topmost manufacturers of those home automations using IoTs. Okay, so that is also basics, but here we are concentrating on industrial IoT. So IIoT is nothing but industrial IoT, where if you want to monitor and control a plant parameters, like for example temperature and the physical parameters of a plant, humidity, pressure, temperature, or whatever it may be, the analog parameter which is being which need to be monitored as well as to be controlled. Okay, so Internet of Things. Okay, here there is a major difference that I could able to identify between IoT and IIoT. So simple household applications like If you start with your project, you simply what you will do, you will turn on with the help of relays and with the help of your mobile phones. You can turn on and off a particular device that is for commercial applications. That is simply called as an IoT. Where in industrial automation, where all the parameters, not like all the parameters, you should, a owner of the company, who's having a different plant at different workstations, he has to monitor how many product at finally have been produced at the end of the day, how many effective, how many defective, how many operators have been worked perfectly, which operator is not worked perfectly, and all those informations in terms of data can be acquired with the help of an IoT. It's data management, data security. So this IoT is the platform where you can acquire data. So this is not you're going to produce the result. Like, so we have buzzwords like data science, data analytics, machine learning, IoT, and all, right? So data science is a very big round. So this like a very big round is called as the data analytics, in which this small round is nothing but a data science, in which data analytics is called as data analysis on the data. How can I analyze the data? I need to acquire the data first. How can I acquire the data? With the help of IoT. How the IoT is acquiring the data? That requires some basic modules like either your microcontroller based hardware or your PLC based hardware. And then the very importantly, you require the communication hardware. Appropriate communication hardware need to be communicate the equivalent data. Okay, and one more important thing here is the front end. How the front end is being developed. Without that, I cannot able to visualize what is happening inside it. Okay. And okay, connectivity of data analytics, what is industrial internet of things and consumer internet of things, simple consumers through mobile phone purchase, all those things based on, like for example, if you are going to search on your Flipkart, your mobile phone today, and tomorrow it will automatically show you what are all the other options which are available under mobile. That is called as the machine learning algorithms. So based on the search history what you're having, the machine itself which can able to learn, like maybe with supervised unsupervised learning, and it gives you a result accordingly. So like for example, in industries, we need to perform optimization, and then quality, quantity of output is the three major parameter in industry. In order to achieve that, we supposed to use the industrial internet of things. Okay, so here I'm going to tell you 7 principles. It is used to perform big data, big analog data problem. It can able to solve big analog data problem. Analog in the sense what? The parameter in the field which is being continuously changed. Okay, like temperature, pressure, flow. Like if the sensor is on and off, that is nothing but your discrete. IoT offers perpetual connectivity. It is really a real time. It has a spectrum of value. It is the time between time to insight and depth of insight, and it is towards the IoT now. It is visibility mode, and data center access compute data analytics shift into the right edge. So that is, I will tell you detail. The first stage, that is nothing but first one is nothing but the 4 stages of IoT architecture, which consist of stage 1 is nothing but your sensors and actuator. Stage 2 is nothing but internet gateways and data acquisition systems. Stage 3 is nothing but edge IT, and stage 4 is nothing but data center and cloud. So the sensor informations, which are wired or wireless sensor information, that need to be given to the internet gateways and data acquisition system, that is analog to digital converters, measurements and control, what we have discussed right now, your local SCADA and PLC systems or microcontroller based hardware, from which the communication medium need to be transmitted the data to the common central server. Your edge IT is called as the this edge IT is to perform data analytics and pre-processing, then the data center, data storage and data analytics, and to perform a decision making functions. So this is what the 4 different stage architecture. 7 principle. First one is it represents big analog data problem. Okay, so this big analog data, whatever may be in your real world, whatever may be the data. So what is the difference between normal data and a big data? So I will show you some of the data which we have used in our application. Like it is not a big data. If lakhs and lakhs of data which you are going to measure it, like if you want to generate a simple coding algorithm for a traffic light control, You know, it is the very big problem in a society as of now, the traffic control problem. So if I remember, one of the DST, they have asked to submit a proposal how to solve these traffic control problem using big data analytics. It means, like for example, you have to estimate it when a vehicle is traveling. Your data analytics must estimate it and what is the shortest route, so that without any for example, without any traffic, how can I reach the destination in a short time period. Okay, so for that purpose, you require big data. It means what? You have to acquire all the vehicle data in one particular traffic control station. That is called as a big data problem. So now it is used to represent a big data problem. Second one is it offers perpetual connectivity. It focuses on three different M's. That is nothing but it can able to monitor the condition and usage of product, device, people, and marketplace. It is used to maintain, that is control the parameter in a particular way, that is in a particular value. It means what? If you want to make the temperature at 49.9 degrees centigrade, it should appropriately do it. But very big disadvantages of using IoT is nothing but the network connectivity. Okay, so if the network cognition which takes place, which cannot able to acquire the data within the fraction of microseconds to a central cloud, it is not possible, right? At the microsecond, I need to perform a control action towards the heater or towards the cooler. What you have to do is, in a local server, if you're having a control in local server, you can able to access the data immediately and you can able to perform control action. But in IoT, if it is not a supercomputer, that's why we are going to offer a cloud. Why we cannot able to store the data in our local server? We cannot able to perform this like AWS, Amazon Web Servers. They are giving us the data storage for a rental purpose. For 1 year, you have to pay 2,000 or 3,000 rupees for 50 GB to 100 GB of data, the data per day, data to be stored on the cloud. So the maintaining is the very important thing. That's why we are going with a supercomputer, fastest computer. It will be working 24/7 without any delay. So and it's nothing but monetize is nothing but, so it complete the employer customer. So it's getting a feedback, and then based on the feedback, it should act upon the feedback immediately. Okay, and then it is really a real time. You're not going to manipulate anything. You're going to get a real time data always to end-to-end industrial IoT solutions. And then data insights gains with a spectrum of value, like in terms of business, in terms of engineering, in terms of scientific. So like for example, if you cannot integrate, like for example, I'm a mechatronics engineer, I'm explaining you. For a mechanical engineer, I'm explaining you what is an IoT. Why? Because we on the day we all require to use this IoT. Without that, we cannot able to focus on the recent developed this advancements like robots, automatic robots, which are being used in the market in a manufacturing sector. I need to be know what is that actually, so that if it is not integrated with all these environments, I cannot able to implement this particular architecture. So this is purely integrated one. It is in all the fields. So IoT presents time to insight and depth of insights. It's not only acquiring a data with respect to time, it also gives a value of that particular data, that is called as depth of insight. That is, it acquires, it analyzes is the very important thing. Acquiring IoT data is being analyzed with the help of data analytics algorithms, and accordingly it performs appropriate actions. Okay, so last one is principle number 6. It is next that is next version of the big data is IoT is visibility. That's nothing but they are concentrating on V's of big data. So that is variety, volume, velocity, and value. So mix of structured and format, different kind of inputs, different formats of input data can be acquired, and with a large amount of data with high speed and high sample rates and importance of analytics. So high valued analytical solutions can be implemented so that you will be getting an appropriate solutions. So like for example, data center class compute shift left to the edge. It means it is towards acquiring the data with latency, high bandwidth, low network cost, and security without duplication, reliable, and all those parameters which are being enhanced to get the higher data output of the IoT. So this is a principle of 7th principle, data center compute analytics, shift left to the edge. Okay, so now let me start with the case study of ours, case study, like investigations on the prediction of fault occurrences in oil pipeline transportation system using IoT. So this is the work that I'm going to explain you was done by my full-time research scholar who have completed research I think 3-4 months back, and she has, and we combined together. Actually, I've developed this particular setup, and she was my student starting from my PG, and we have started developing that particular setup. Now we have published around 10 to 12 papers in this with the highest impact factor of 10.616. Why it is, why I'll tell you what are all the things that we have done. Okay, once if you're working on research perspective, if you want to use IoT, please clearly look into it. If you have any doubts, please ask me. Okay, so first title is your prediction of fault occurrences in oil pipeline. When you want to transmit oil over a longer distances, what will happen? Through a longer distances, there will be a problem of leakage and cracks. Due to the cracks, the leakage may be occurs. Due to high pressure, the data flow will not be takes place immediately. So this is some sample documents, what are all the problems which are being occurred. And this is the pipeline cracks occurs with respect to time. And this is again data which tells you the station wise. So there are different stations like pumping station, distribution, different stations which are being available for pipeline transportation, and where the maximum crack or leak occurs. So that it shows this data, and this is a setup which we have fabricated. Now I need to concentrate on, so since we have half an hour more, I need to concentrate on this particular setup, right? So this is a setup we have fabricated in our laboratory. This setup we are using for the students, those who are doing laboratory experiments. This setup we are doing for research purpose also. Like if you look into it, like for example, if you cannot understand this control mechanism, like please understand like it is a manufacturing plant, since I don't have any real-time example from manufacturing plant. Okay, like mechanical manufacturing. So it is the plant where we have simulated the industrial oil transportation system. We have 3 different stations. Okay, this is station 1, this is station 2, and this is here we have station 3. That is 1, 2, and 3. Total 3 sets of pressures and 3 sets of flow rates will be measured, and then the flow rate can be controlled with the help of control valve. And this is a HMI local SCADA screen, what I have told you. And this is the PLC experimental hardware, and this is PC is for programming. Okay, so this is a simple setup. What you have to do is simply from this oil well pipe, the oil which will be transmitted over here we have fabricated for totally 1 kilometers of distance. So here in this control station, the flow rate is being measured. So what is my objective is to measure the pressure and flow rate at the different places, and I have to indicate to the operator when the abnormal pressure which is being takes place locally, and I need to store the same data in the cloud, and I need to estimate what. So now today for 3 months of time period, this will be the abnormal pressure which is being takes place, and when the crack or leak will be occurred. That is what the data estimation that we are going to do. So this data estimation in future we are going to do with the help of the data clustering algorithms, that is called as the machine learning algorithms. So this is what the experimental setup. So this interfacing diagram, this what is called as transmitter, all these analog parameters. So these are all analog parameters which are being interfaced with the PLC, and this PLC will be converting digital data, and with the help of set point, some controller is taking a control action. No need to worry about this. Some sensor data which is being interfaced with the PLC. So that is enough for you. And next one is, this is the HMI, like, or a SCADA. Okay, I have explained you what is called as a SCADA screen. So this is SCADA screen. It is the replication of a simple oil station. Like this is in a field. Here I'm going to draw like a reservoir tank and pump and all those things. Here what I'm doing is, here I'm going to indicate. So which pressure valve is on, what is the actual pressure it is showing. This is off, this is off. This is also in off condition. This flow valve is in, it is used to give you some output. It is in green color. What is the tank level? If you have sensors, it shows you the tank level, everything can be visualized with the help of the HMI screen that we have developed. So here is the trend, that is with respect to time, what is the pressure on each and every field that is being takes place. So now we have the oil station 1 and then we have oil station 2 also. So that oil station is different. So this is a DCS based oil station 2. Here also we are having pressure as well as flow can be monitored with the help of input output hub module through the engineering station. Okay, so this is we took for research purpose, we took from DCS plant, no need to bother about this. And now this is the integrated IoT architecture. Now you have to look into it. You have some sensor data in your, based on your research, you just assume you are having some input data, how it can be monitored. So this smart IoT module, I'll tell you, this IoT module we have fabricated in a customized manner. So we have our alumni who completed his MTech from Sweden, who helped us to develop this IoT module for our. So since before 4 or 5 years, we don't know what is an IoT is, how to interface IoT and all. And he came from, after his completion of this MTech, he has started his startup, and he did his startup from our TBI, and from him we can able to obtain this IoT, smart IoT architecture for our specific applications, not like general IoT hardware we haven't tried with. So what I have tried with this, I need the how many IOs input outputs, I need these input, I need these facilities with this. So with the help of that, we have fabricated a smart IoT. Like this pump, and this is station number 1, station number 2, and all these data can be communicated to your IoT module. So this IoT module consists of what? This consists of IO connectivity. The sensor data can be directly connected, or it can be connected through a PLC. So why do you require PLC? If the IoT fails to perform control action, you require a local intelligence. So local intelligence means what? If due to network problem, if IoT is not working, then what I can do? So there should be a control mechanism need to be implemented at the local station. That is what being performed with the SCADA and PLC at the local station. So this controller module, directly you can give the input to this IO also, through PLC also you can give it. This controller, I will tell you, it's simply an Arduino based. This Wi-Fi module, we have used Bolt IoT module, and then at the cloud server, data storage takes place and data analysis also takes place. So here at the field, we have SCADA based PID controller at the local intelligence part. That is your local intelligence PLC part, which is being available. So this is what the integrated IoT architecture. So what are the layers? Sensor level, it will be transmitting. So at the application level, you have local intelligence, SCADA and PLC. And then at the application part, you centralized database, cloud computing platform, web servers, data store, and real monitoring system, everything is available. So now this is what the smart IoT module which we have fabricated. So this H-link is nothing but it's a common link. So if you might have seen all big rectifier circuits which are being available, but we took a very small H-link. So this H-link is the device which is used to convert your AC into 5 volt DC. So here simply you have Arduino Uno micro controller. So here it has been given this Bolt IoT module. This rectifier is your H-link. So this Bolt IoT module is given here. So this Bolt IoT module, and then this is called as your Arduino Nano. So this box is Arduino Nano, and we have relays. And then relays are the output devices to be controlled, and digital inputs and analog inputs. That is when it is voltage as well as current. So input, whether it is voltage or current, that can be interfaced. And this is nothing but analog output, AC1, AC2, and AC3, AC4 and all. So this is what the simple smart IoT architecture. Don't imagine like a very big thing which is available. If you ask someone to design and fabricate this, they will simply give you. So here the new one is this Bolt. This Bolt IoT module is the new one. So this Bolt IoT module is available in the market. You can purchase it. So they will be providing you a separate, once you interface it, you can have login ID and password to your cloud, and data storage can be possible. And for front-end developed system, you have to ask a help from a computer science engineer to develop a front-end using Java or a Python or simple HTML coding. Okay, so this Bolt is having so individual Bolt hardware is having an individual storage area. where you can look into it. The data can be, first what you have to do is, I don't know whether I'm having the further slide. No, here I need to explain you how it can be interfaced. So like all the sensor input will be given here. The sensor input will be given here, need to be given to the Arduino Nano microcontroller. What it will do is, it will be converting serial data. So serial data transmission is very important. Serial data will be transmitted through this Bolt IoT module. So this is the Wi-Fi communication module, where through wireless transmission, the data can be transmitted. This data can be transmitted with the help of some, how can you receive? With the help of API keys. So application user interface keys are being available at the front end. Through that, you can able to acquire the data. So these are all some basic things that you required, how to use your Arduino, how the serial monitor being used, how the data is being transmitted, and everything you're supposed to know. Like, then you are going to transmit through a Bolt IoT module at the front end of your PC. So what are all the credentials that you need to do? Look into it. It's a high level online IoT operator interface. So here for individual Bolt IoT module, individual IOs, you'll be having a separate API keys. Okay, and then this is nothing but your login credentials, the email notification will be sent, all those security informations which are being available. So this is a front end based on the API keys that you are receiving. So here we have pressure 1, 2, 3, 4, and then this is nothing but real-time manipulated sensor data. So this is from station 2 and this is from station 1, and you are going to check the alert. So whether serial data is okay, serial Wi-Fi is okay, where data is read or not, everything you can check it at the front end from the serial monitor. This you have to develop. So this already coming through your Bolt IoT, that is API credentials and all. This login details also coming in this front end. You have to develop with help of HTML or your Python or whatever it may be your coding. So this status of Bolt, like here, whether serial data transmission takes place, whether it is success or not, serial data write on this your Bolt IoT, whether it is success or not, serial read. What is the difference between write and read? If you want to send some information, control information to your hardware, that is nothing but you are going to write the data onto your microcontroller. That is called as a serial write. So this is analog write and read data. That is based on the input, whether it is success or not. You can. So if it is not success, it shows its device offline. It is non-registered. It is in offline. Okay, without it online, it shows you the indication status like this. And after that, this is the front end that you have to develop. So this front end, all the informations like whether it is alive, all the condition status and all, the same thing which I have shown you in previous slide. So here the very important thing is the pressure data with respect to time you can monitor. So what is the monitoring set point? If it is not in the set point, it will automatically send you the digital output using the digital write to the embedded hardware. So this is what you're from the front end. So as a mechanical engineer, how I can do, I don't want to understand how the data is being transferred, what a serial and all. I don't want to bother about that. You just, if you can able to access this front end, you can able to store the data and you can able to process the data. Okay, so this is a simple front end. So here, how can I make the decision? Like if the pressure is in emergency setup, what is the pressure condition of the station 1 as well as in the station 2, and when I should activate the shut-off condition. So these coding should be written in your HTML coding so that it will be sending the appropriate control signal through the Bolt Wi-Fi module to the microcontroller hardware. Then the microcontroller hardware sends the output to your output device. That output devices will be connected to the real output hardware. Okay. And then so this is nothing but your next thing, what is called as of now I have explained you what is simply an IoT, how this IoT hardware can be interfaced, how the data is being transmitted, and then now you store your data, how the data processing needs to be takes place. That is very, very important. So here in our example, so let me show you this diagram. In our example, oil pipeline. So yes, so this is an oil pipeline. When the crack and leak occurs, it based on the pressure which is being built inside it. So what we are going to do is, on each and every station, we are going to connect different sensors, that is wireless flow as well as pressure sensors. that will be transmitting data to the local module. Like for example, we have a simple module in laboratory setup, we have IoT module. What you will be replacing that IoT module in an actual field, we have to use LoRa. Like LoRa is the communication module, is the most commonly used communication module, IoT communication module, which is being used. So different stations, like every 1 kilometers, I need to place a LoRa module, so that without any wired communication, here for example, you are going to place a sensor. From that sensor, the data can be communicated through the to the LoRa module. Okay, so that communication data is being takes place, and then you can develop a front end, and that front end tells you what is the normal and abnormal condition is. Okay, like now it shows the pressure. Now I need the historical data. Now we are going to the next step of data analytics, your data science, like called as the storage of historical data and how to process a historical data. So once you store your historical data, you have to identify. For our application, for 4-5 days, we are going to store 20,000 to 50,000 data. In order to analyze this data, big data analytics is not required. If the data is more than 1 lakh, then you have to go with big data analytics, else you can go with some data analysis algorithm. So what we have used is, we have used the data analytics as k-means clustering algorithm. So this k-means clustering algorithms, which works on based on this simple flow chart. So when you have to choose some k point as the elbow point, is the midpoint, is nothing but the normal pressure. You have to measure the Euclidean distance, and then grouping based on nearby centroid value. So there is a mathematical and statistical analysis need to be involved in this k-means clustering algorithms. You have to develop it. So how can you develop k-means clustering algorithm? You can use either Python, okay, or some MATLAB based coding is also available. We have used Python based algorithm for developing this. And frankly speaking, I don't know the basics of Python and all. And I asked the computer science people to do this, and they have explained me, and they have given us the solution. Like we have given them data, 20,000 to 50 data, and we asked them to train like this, and they have given us the result. Like here is the result. So this is nothing but a normal data, where these two data clusters are being coupled together when it is abnormal. So the centroid distance between the normal and abnormal data will be much more higher. With this graph itself, we can identify that the data is not in a that is there is some abnormalities that is being takes place in the system, like abnormal pressure data which is more in the system in your field. So that based on this, you can able to estimate it. So like next one is nothing but prediction of future fault occurrences. So I haven't given you the much detail about this. This is nothing but time series forecasting algorithm we have used. It's called as time series forecasting algorithms. This algorithms we have developed using R software. So R software mostly used by the management people. For what purpose they are using us? They are using it for predicting the future stock values. For example, I'm telling you. So what is the stock value today for a particular product, and what will be the, your market price for in a future after 2 months or 3 months? They can able to predict using a software called as R. So that software we have chosen, and using that software with the help of k-means clustering results, we have given as the input, and with the help of that, we can able to estimate what may be the future fault occurrence that maybe takes place in the oil pipeline. Like for example, you have to feed the data for the year 2017. So 2017 second quarter and 2018 2 quarters, and then 2019, and you can estimate the data on 2019, what was happened during, what will be happened during 2019. A year back we have done actually. So without giving any set of input data, so you can able to estimate what may be the predicted output value. So what is the possibility of future prediction? So this I can show you like a graph. So this graph, what it shows you is this station 1 and time series forecasting. So this is a predicted value. It is shown in red color. This is nothing but this blue color indicates this, purple color indicates the deviation from the mean, and this common mean average. So this is common mean average, and this common mean value which is being predicted on time series forecasting algorithm. So this based on this, I can able to estimate what may be the future fault which is being occurred. So if the abnormality of the pressure which is being takes place with respect to time in this particular year is being like this, what may be the future? Okay, so this you can able to predict it, and you can able to estimate the lifetime of that particular pipeline. So this is what you can able to done. So you can able to do with the help of this IoT, data analytics and prediction algorithms. It is called as data analysis, otherwise it is called as machine learning algorithms. K means clustering algorithm is a supervised machine learning algorithms which is being used to perform the plant estimation function. Okay, so this is what we have done. So one more case study. So you have any questions in this? Ask some questions in this case study one. Yes, no one. Yes, since I'm monotonously speaking, I would like to get some feedback from you all. Actually, I thought of having a different way of presentation, but today in Tamil Nadu, all the colleges today gets closed, so I have to sit in my house. Though I don't have any digiboards and all with my hand, so I need to speak monotonously. And sorry about that. And I think you might have understand some of the basics things about this. Okay, like next one is your case studies 2 is nothing but your estimation of future fault occurrences in simple phase induction motor using Iot. Is a simple problem with the help of the concept called as digital twin. Digital twin in the sense what when the motor failure which occurs that can be estimated with the help of the MATLAB based software that is called as digital twin. Twin is the most important concept. Now it is being practiced by the industries. Okay, when the failure will occur, for example, you are having a grinding wheels in your industry, it is used for grinding purpose. You can estimate the total running time period of that particular grinding wheel, and that can also be possible, like for example in manufacturing sector or in mechanical way, you can save so many examples. So here what we have taken is we have to analyze the fault occurrences in a single phase induction motor using industrial material handling system. So this is a motor which is being used in industry for material handling purpose. I need to estimate, so it is being continuously working for 24/7. I need to estimate the this motor how long it will be working perfectly. So if it is
Ma'am, actually there is a network connection issue. Ma'am,
yeah, one second, sir. My connection was lost. Yes, sir. Am I audible right now, sir? My
yes,
screen
ma'am.
is visible right now. Okay, thank
Yes.
you. Yes. Yeah. So this simply is nothing but the same thing. Once you understood the basics of how the data is being occurred, all the case studies will be look like the same. Like the sensor parameters, temperature. Here from the motor, what we are going to measure is first one we are going to measure the temperature. Second one we are going to measure the vibration. So temperature inside the bearing, that is it has stator and rotor coils. Inside the stator and rotor coils we are going to place so many temperature sensors, and then we are going to measure the vibration also. These are all the two basic estimated parameters that will tells you the total running time period or the quality of the motor which is being used for a longer time period, and that will be estimated. And then for a particular manufacturer, I can able to estimate it. For example, if you are taking a Kirloskar motor, then I can able to tell you this type of motor for this application, if you are using this will be working for 8 or 10 years only. So this is what the estimation that we can able to give. That is what the purpose of digital twin. As of now in IoT, the main important application which is being used is called as the digital twin. So like this is a simple experimental setup which we are having, a simple motor, uh, single phase induction motor which is used for conveyor purpose, which is in our lab. And what we are going to do is we are going to connect sensors here, like vibration as well as temperature sensor inside it. So that will be given to a PLC. Since we require a local monitoring and control, so we are giving through a PLC. But why we are always looking into PLC? Because it gives us only the if once you use your Arduino microcontroller and all, it will not producing an appropriate result when you want to get an output. Like this PLC is a versatile device. IO error will not be occurred, programming error will not be occurred, interfacing error will not be occurred. However, in some case, if some failure occurs, we can able to easily rectify it. That's why most commonly we will be using PLCs alone. So then we will be having vibration sensor, and that will be transmitted. Okay. So here also the same front end. Once you develop so we have the same common IoT module. So that IoT module, we are going to connect this oil pipeline input outputs, and once we disconnect it, we can connect this motor inputs like your pressure as well as, sorry, not pressure, it's a temperature and the vibration can be interfaced. So like the same front end, I can able to replace it instead of IP1, IP2. I can able to give us the pressure as well as, temperature and the vibration signals. So with respect to time, we can able to analyze it, and then we can able to estimate the, based on the historical data, we can estimate what may be the when at how long time period this will be working out. The motor can be worked out without any problem. How can you estimate it? You have to have the maximum range of temperature as well as the vibration. If it occurs for multiple times, then you can able to estimate that with the help of k-means clustering. You can cluster the normal, abnormal temperature. You can cluster the your vibration, normal vibration and abnormal vibration, and based on that you can able to estimate it. So that is what the digital twin concept. And third one is few more slides, now 1241. Third one is, so this is in development stage. This is what an exoskeleton assistive robot to lift a heavy weight in industry. So we are planning to develop an exoskeleton. Since it is mechatronics, we are dealing with robotics as well as in automation, two different hubs. So exoskeleton is nothing but an additional wearable bionic device by the operator, like for example soldier in a war who can able to lift a heavy weight, or if you want to industry, if you want to lift a heavy weight in an industry, you can use it. Okay. So here I can use IoT as well as artificial intelligence here in order to make a decision automatically. So in today's world, there is an increase in demand for lifting heavy weights in cramped spaces. Any device with less weight and modular approach is really welcome, providing rehabilitation of parameters and can act as a physiotherapy trainer. So there are different purposes by which the exoskeletal assistive device can be used. So the applications for these devices will be, it's a modular approach and it can able to lift heavy weights. It is an alternative solution for prosthesis, and it can be used in defense also, and it can able to use the physiotherapy trainer for in a hospital. Like you can see some of the exoskeletal applications where Sacros exoskeleton, which is the exoskeleton which is being used, which is tested with the help of robots also. So here it is a crane, and these exoskeleton device can be used to lift a heavy weight. So here the Bleek's prototype is the source which have been created. So here this exoskeletal assistive mechanism which is being connected with the war soldiers. So heavy weight is being lifted with the soldier with the help of this device. So these are all the already patented application devices. XR exoskeletal device, this can be a wearable one, but here this thing is it itself carries some 10 to 15 kgs, and in addition to this you have to lift more weights. It should not affect the lower and upper limb of the human body. So those are all the things that need to be studied. So it should be operated in remotely, so that all these parameters need to be monitored as well as controlled through remote also. So like how can we design so this is what simple skeletal device which we are having. So this we have developed with the help of aluminum bars. So this is with the help of linear actuators we can able to operate it. You can use the servo motors for this joints also. This linear actuator is having 70 newtons of capacity, which can which can able to withstand the weight up to 100 to 150 kgs. You can able to lift the maximum weight, but here the main disadvantages of the developed exoskeletal devices, it weighs up to 26 to 27 kgs. But the human, once the human is wearing this device, he will be affected from so many the shoulder pain problems and hip pain problems. Everything was also available. So this need to be redesigned, and we supposed to refabricate it. This is what the exoskeletal research which is going on now. And here also we are going to fix the same IoT module for monitoring the that is if it is being remotely operated. So if the human is wearing, if some problem occurs, if he cannot able to communicate it, this smart device need to be communicated to the central host server. With the help of that, the server have to make a decision. So this is what the remote monitoring functions which is which is going to implement on this, but it is now in the development stage only. So okay, so thank you so much for your patient listening. I think time is 12:45. I think I've completed on time. And if you have any queries, can you please ask me? Yes, sir. Any queries from your side?
Thank you, madam. Any queries from the audience? Audience, please, any questions? It's time to clarify your doubts.
Madam, good morning, madam.
Yeah, good afternoon, sir. Tell me.
Good afternoon, madam. Actually, your presentation was very good, madam. You are nicely explained the three cases. Actually, entirely these three cases are different cases. I am also from instrumentation department.
Okay, sir.
Actually, I have one more doubt, madam. What type of cyber security you are using, madam?
Yeah, actually, the very important question that you have asked, sir. That is what the very big important problem with us. Right now, we haven't used any cybersecurity algorithms for transmitting a data. So while secure transmission of data is very much important, since we are looking into the plant monitoring and control functions, but as of right now, we haven't concentrated on the cybersecurity. But the same questions that is being asked by the external member for my scholar, what type of security algorithm that you have used, so that we are looking into it. Next problem, now we are working into this welding mechanisms. We are doing the same digital twin plus IoT for welding applications. We are going to estimate some certain parameters. So in that, we are looking into that, how to implement it. Right now, I don't have any idea of how to implement this, but we have asked the help from computer science people. But we have collaborated with them, sir. The computer science and people, they are helping us to develop all these front ends, and we have some problem occurs that they are helping us. But totally as an instrument engineer, so we are just concentrating on trapping a data and developing a local intelligence and control algorithms. That hardware part we can able to do that, but those part, programming algorithms part, it has to be worked it out. So that data security is the very big issue while transmitting a secure data. Thank you, sir.
Thank you, madam.
Thank you, sir.
Any other questions from the audience? Thank you, ma'am. So if no other questions, we can wind up. So thank you for the wonderful session, for the detailed session. So let me invite Baby for the vote of thanks.
Yeah, thank you.
Thank you, Dr. Maheshwari Madam. Your session on smart and integrated PLC IoT architecture for plant monitoring and control was very informative. On behalf of entire Vishyoti College of Engineering and Technology, I extend our sincere thanks. Thank you, Madam.
Thank you so much, sir. So thanks for the opportunity given, and thank you, everyone.
Thank you. Thank you once again.
Thank you, sir. Thank you, sir.